Hello everyone, we are group 26. I'm Selam, and we also have other team members, Suji, Arthur, and Damia. So today our group will present our assignment 3 for HIT391 machine learning to develop the clustering algorithms and classifier algorithms. And this is the outline for our presentation today. The first part is the introduction about our project, and then we will describe the data sets, and then we will also introduce about the clustering algorithms, including the k-means methods and hierarchical methods. And the next part is the classification algorithms, including the logistic regression and also the random forest methods. And the last part is the conclusions. In this project, we will apply the machine learning techniques to develop two algorithms. The first algorithm is focused on the clustering individuals based on their hobbies and interests using unsupervised learning methods. And the second algorithm is implement the classifier algorithms to predict the survival outcomes of the Titanic scenario. We will use two datasets for this project. The first dataset is cargo interest group.csv. This dataset for clustering algorithms, and it includes 6,340 individuals with binary indicators across 217 interest categories. And this dataset is unlabeled dataset and suitable for unsupervised clustering. And the second dataset is Titanic machine learning from disaster for classification algorithms. And this dataset include three other subdatasets: trend CSV, test CSV, and standard submission CSV.
Hi everyone, I'm Damon. I'm talking about data processing. We have to preparing the dataset for clustering analysis and the training details. And the next one, I'm talking about data splitting the dataset for training, evaluation, and testing. Dataset splitting into 60% train, 20% eval, 20% test. This separation allows for model tuning and unbiased evaluation. And the third one is the model implementation, setting up clustering algorithm and tools. Two clustering model was selected, imported all sensor libraries, model were initialized and prepared in this step. Actual training and evaluation are done in the next phase.
After we do the data pre-processing and data splitting and also data implementation, we will continue with the training model using k-means methods and hierarchical methods on the training datasets. And the training datasets cargo interest group CSV will split in 60% for the training dataset, 20% for evaluation, and 20% for test dataset. And the optimal k equal to 5, we will use the alpha method to find the best k for the k-means methods. And the model will train with the k-means and cluster equal to 5 and random state equal to 42. This is the alpha plot for the k-means method algorithms. We can see the x-axis is shown in number of cluster and the y-axis is shown in the sum of square distances. And there's 5 cluster on the alpha plot. That means we can use 5 cluster to implement the k-means methods. This is the results for the k-means clustering on the training datasets. As we can see, there are 5 clusters that can be used for the k-means clustering on the training datasets. And we also can see the final inertia sum of square distances from each point to each cluster centers were equal to 15,895.29. The second method we use for model training is hierarchy co-clustering. For the second method, we will use agglomerative hierarchical clustering with the word linkage on the training datasets. We also apply 5 clusters consistent with the k-mean result to implement the hierarchical clustering. Also, we will fit the model with agglomerative clustering with n cluster equal to 5. This is dendrogram for hierarchical methods on training dataset. From the dendrogram, we can see there are 5 clusters allocated from 0 to 175. And we also are using this one to predict the best case for the hierarchical methods. We also use the agglomerative clustering to implement the hierarchical methods with n cluster equal to 5 and word linkage. In the next step, we will do the model tuning for k-means and hierarchical methods using the COLS score matrix. We can see the best score for k-means method is nearly 0.7 for 2 clusters, and 5 clusters still retain for balance between interpretability and performance. For hierarchical tuning methods, the best score is nearly 0.8 for 2 clusters, and 5 clusters still retain for deeper segmentation consistencies. For the model evaluation, we will use the testing dataset to do the evaluation for the k-means and hierarchical methods. And from the table, we can see that the accuracy and recall score for k-means and hierarchical methods had the same number from 29.67%. However, the precision and F1 score for k-means methods is higher compared to hierarchical methods.
Hello, my name is Sui, and today I will be presenting our group's work on Task 2, Titanic Survival Prediction. In Task 2, our main focus was to create classifier algorithms that could predict which passengers made it through the Titanic shipwreck. We set out to build a model that would effectively leverage passenger information, such as their name, age, gender, and socioeconomic status, to deliver accuracy predictions. The first important step in our progress was getting the data ready for analysis. We kicked things off by loading the dataset with the help of the Pandas library. After that, we took some time to explore the data, which helped us grasp its structure and spot any missing values. To tackle those gaps, we filled in the missing ages with the median age, replaced and the missing impact values with the most common one, and used the median fare to impute any missing fare values. We also added some new features like family size and title to see if they could boost our model's performance. In the end, we scaled the numerical features using standard scaler to make sure everything was on a similar scale. Next, we took the pre-processed training data and split it into two sets, one for training and the another one for evaluation. We decided on an 80-on-20 split, which means 80% of the data went into training our models, while the remaining 20% was set aside for evaluation. This division was crucial for the tracking how well the model performed on new unseen data, and for fine-tuning the hyperparameters to make it as effective as possible. For our model implementation, we decided to go with two different classification algorithms, logistic regression and random forest.
Hi, I'm Atul Matthews, and I will be presenting the model training, tuning, and evaluation that we have done on this assessment. So on this slide, I'll be talking about a model training overview. We trained logistic regression and random forest on the Titanic dataset. We balanced class weights and tuned hyperparameters. Learning curves showed logistic regression generalized better, while random forest overfit but showed higher training accuracy. As key results from learning and tuning, random forest outperformed logistic regression in F1 score. Logistic regression's coefficients revealed top predictors, and random forest deeper trees and more estimators improved scores. Training time was much longer for random forest. Parameter tuning insights. Logistic regression worked best with small c-values. Random forest benefited from deeper trees and More estimated high parameter tuning clearly improved performance for both. Evaluation results. Random forest perfectly classified the test set. Its ROC and PR curves showed ideal performance, and it produced better calibrated probability estimates than logistic regression. So we're moving to the final modal comparison. So we found that random forest outperformed across all evaluation metrics: accuracy, F1, precision, recall, ROC, AUC. It was chosen as the final model due to its robust performance throughout our assessment. Thank you.
In conclusion, we successfully implemented both logistic regression and random forest models to predict Titanic survival. Thank you for your time.